So introduction to networking. In networking, there are two types of networking. That network in which the network is, or in which the computer is connected, peer-to-peer and server-based. So what is peer-to-peer? The devices share the link equally, meaning this device, this and these are all connected equally. So they will be sharing the links equally. Whereas in server based, one device called the server controls the other devices called the clients, and the clients will transmit through it, meaning this device here is a server and all these are clients. So whenever the clients will need any information, any file, it will go to the server. So they will transmit through the server for that particular file. So peer to peer, the devices share their link equally. In server base, there is one person who is the main, that is a server, and the clients are controlled by the server, and the clients have to be transmitted through the server. So in the networking, you have two types of networking, that is peer to peer and server based. Next is, what is a network? A network consists of two or more computers connected together, and they can communicate and share resources, example information. So if you can see, this is a network where the three computers are connected to each other, and there is a server. So these computers are called as clients. Even this is called as a client. So all these computers are connected together and they can communicate with each other. This computer can communicate with this computer to share some kind of information. That information can be some kind of a file, some kind of a audio, video, image. Any kind of information can be shared from one computer to another computer when they are connected in the form of a network. Why do we need networking? Now the question arises, why networking is actually needed? So we need networking for data communication. So there are two options given to you and they have asked you which one you prefer. So in this, there's a first option. What is being done? From one computer, memory, or you can say information, is being taken out and then it is transferred to the other computer. So for example, let's take a pen drive. In pen drive, you take information from one laptop or a computer and you insert that pen drive into another computer. So what is that pen drive? That pen drive is a external device which is used. But when the information is of a larger quantity, you cannot go with the pen drive method. You need something so that both the computers kept together, kept in a network, you can share the information without any kind of external device. You need some method. So we would obviously prefer this when the data is larger, the quantity of data is large. We will prefer this kind of a method where one computer connected to the other computer, you can share the information, the data, without the need of any external device. So this is what you will prefer. When larger data is there, you will prefer this method. Now, sharing hardware or software, example, print documents. You have a printer and this printer will be connected in a network to many computers, and you can print using any of those computers. So they will be connected to many computers and you can print using any of the computer. Centralized administration and support, example, internet based, so everyone can access the same administrative or support applications from their PCs. So there is a centralized internet. That internet will be connected to all the computers. So that is what? That is networking. When a single network internet is connected to all the computers, a single printer is connected to all the computers. That is all which is there in networking. You are creating a network amongst the printer and the computers, so that you can use that one and only printer for all the computers. So your resource, you are saving the resources. Network goals. What are the goals? Exchange data. You can exchange data between two computers. When the data is a large amount of data is present, then you need networking. Resource sharing, for sharing of resources between the two computers. Saving money. Obviously, in case of a printer example, you can just buy one printer and connect it to as many computers as you want. You don't have to buy one single computer with one single printers. So you can only have one centralized printer connected to all the computers. Easy administration, scalability. Centralized storage. You can have a centralized storage where there is only one server where everything is stored up, and when the client will request for the data, client requests for data, that data can be removed from the server. So that is a centralized storage. Powerful communication medium. There will be a powerful communication medium because it will take lesser time. Next, network applications. Three broad categories: information exchange, resource sharing, interactive environment. Now, how many kinds of networks are there? This is a question. Depending on one's perspective, we can classify networks in different ways based on the transmission media. So there are two types of transmission media. One is wired and the other is wireless. Wired media is also called as a guided media, in which the data, there will be a link created between the client and the server with the help of coaxial cables, UTP and fiber optic cables. And wireless media is your unguided media. Unguided media, the transmission takes place with the help of waves, electromagnetic waves, in which you have radio waves, microwaves are there, then you have radio waves, and we have infrared rays. So the transmission takes place with the help of infrared waves. So transmission is taking with the help of the electromagnetic waves. In case of a wireless media, so you can divide the networks into two medias: wired media, wireless media. You can different kinds on the network size: LAN, WAN and MAN. What is LAN? Local area network. Wide area network. And MAN is manual area network. So you can divide it on the basis of the network size. Based on management method, peer-to-peer and client server. We already saw peer-to-peer means one device, the devices, they are equally connected up, so they are shared, the link is shared equally among all the devices. In client server, the server is the one who is in charge of the whole system. So there is one device which controls and the other devices transmit through it. That means the clients will transmit through it. Based on the topology, that is the connectivity, there is bus topology, star topology, ring topology, You even have mesh topology, you have tree topology, and you have so on. So we'll learn about the different topologies in the upcoming lecture. LAN, WAN, MAN also we'll learn in the upcoming lecture. This part comes in module 2, which also we will learn, and even we will learn about management methods. We have already seen a glimpse of what they are. Now, next part is LAN, MAN, WAN. Network in small geographical areas, room, buildings or campus is called LAN, local area network. Network in a city is called MAN, metropolitan area network. Network spread geographically, country or across the globe is called WAN, wide area network. So you have the three networks, LAN, WAN and MAN. What is the LAN network? LAN is local area network. Then WAN is wide area network. Wide area network. And MAN is metropolitan area network. So these are the three networks. Next is communication systems. Communication systems made up of combination of hardware and software. Data communications include transmission of signals. Signals passing through the communication channel can be digital or analog. Analog signals, continuous electrical waves. Digital signals, individual electrical pulses. Now, basic components of a communication network system. So in a communication system, what are the basic components of a communication system or a network? Communication network, we say a message. Message can be in the form of a text, an image or an audio or a video. You have a sender. Sender will send some information or a message. Receiver will receive that information or message. There will be a transmission medium, path by which the message travels. So it can be a unguided transmission medium or it can be a guided transmission medium through which the message will pass. Protocol, set of rules that govern the data communication. So what is protocols? Protocols are a set of rules which have to be followed when you are transferring the message from the sender to the receiver. Sender has transmitted the message. We cannot assume that the receiver has received the message. So there are certain rules which have to be followed while you are communicating between the sender and the receiver. That rules of data communication are called as protocol. Transmission media is the path. Receiver will receive the message, sender will send the message. Message can be in the form of text, image, audio, video, etc. Now, data flow. Communication between two devices can be simplex, unidirectional, half duplex. Each station can be transmitted and received but not at the same time. Full duplex. Both stations can transmit and receive simultaneously. Now, let's see this communication model. In the communication model, you have a source and then you have a transmitter. What will the transmitter do? Transmitter will interpret the message. So transmitter will interpret the message which is sent from the source computer. Then this message will be sent across a transmission medium. Sent across a medium. This message will be received by the receiver. The receiver, what will the receiver do? Again, the receiver will interpret the message and will send to the destination computer. So this is the destination system, this is the source system. So workstation is the source, transmitter is the modem, it will transmit the message. Transmission media is a public telephone network. Again you have a modem and then you have a server. Server is your destination, workstation is your source. So this is their input. Information is in the form of a text which will be received by the source computer. Source computer, digital bit stream, it will pass through the transmitter. Transmitter will interpret the message and send it in the form of an analog signal to the transmission media or the transmission system. The transmission system will again send the message in the form of analog signal. The receiver will interpret that message, convert that message from the analog signal to the digital bit stream and send it to the destination computer. The destination computer will produce the output of text. Communication task, transmission system utilization, interfacing, signal generation, synchronization, exchange management, error detection and correction, flow control, addressing, routing, recovery, message formatting, security, network management. All these are the tasks of communication. This is what technology applications: voicemail, Twitter, email, instant messaging, chat rooms, news groups, telephony, video conferencing. Now next we learn about the network topology. The network topology defines the way in which the computers, printers and other devices are connected. So the way in which the different computers, the different devices, different printers are connected with each other on a network. A network topology describes the layout of wire and devices as well as the paths used by data transmissions. So first is the most common one is the bus topology. Commonly referred to as a linear bus, all the devices on the bus topology are connected by one single cable. So we can see there is a one single cable. And what are these? These are the devices. All these devices are connected on this one single cable. Next is the star and the tree topology. The star topology is the most commonly used architecture in the Ethernet LANs. When installed, the star topology resembles spokes in a bicycle wheel. So if you see the wheel, then it is this way only. This is a star topology. Larger networks use the extended star topology, also called as the tree topology. This is your extended star called as the tree topology. When used with network devices that filter frames or packets like bridges, switches and routers, this topology significantly reduces the traffic on the wires by sending packets only on the wires of the destination host. Next is ring topology. This is your ring topology. A frame travels around the ring, stopping at each node. If a node wants to transmit data, it adds the data as well as the destination address to the frame. So what will happen? There will be a frame and this frame will pass through all these networks. If there is a computer, say this computer wants to transmit, then what will it do? If a node, that means this is a node, this node, that is nothing but a device or a computer, wants to transmit data, it adds the data as well as the destination address. So on this frame it will add that data, that is that information, and it will add the destination address of the computer to which it wants to. Suppose it wants to transmit over here, this person is your receiver, then it will add the destination address of this node. The frame then continues around the ring until it finds the destination node. So this frame will travel across this one, this second node, this third node, and then at the fourth node it will find that the destination address is matching with that of the one written on the frame. So it will say that this is your receiver. So it will pass throughout the whole ring, and when it finds that the destination address is matching with the destination address written on the frame, it will say, okay, this is the receiver. The frame then continues around the ring until it finds the destination node, which takes the data out of the frame. Single ring, all the devices on the network share a single cable. So this is your example of a single ring. All the devices, they are connected via a single cable. The dual ring topology allows data to be sent in both the direction. This is my dual link dual ring. Two links connected in the same networking device. So it will allow the data to be transmitted in both the directions. So one is a single ring where you have a single cable. Dual ring, you have two cables are connected, and it allows the data to be sent in both the directions. Mesh topology. The mesh topology connects all the devices to each other for redundancy and fault tolerance. It is used in WANs to interconnect LANs and for mission critical networks like those used by banks and financial institutes. Implementing the mesh topology is expensive and difficult. So this is my mesh topology. Network components. Physical media, interconnecting devices, computers, networking software and applications. Networking media. Networking media can be defined as the means by which signals, that is the data, are sent from one computer to another either by a cable or a wireless means. So networking media is nothing but a transmission media. And this transmission media is your module number 2, wherein you will learn that how the data is transmitted with the help of cables: UTP, STP, coaxial cable and optic fiber cable. So UTP, STP is shielded twisted pair cable and UTP is unshielded twisted pair cable. So 3 cables are there: twisted pair cable, coaxial cables and optical fiber cables. Wireless media is a unguided media which is using radio waves for transmission purpose, microwaves, and you have infrared waves. Interconnecting network devices, hubs, switches, routers, wireless access points and modems. So these devices are used to connect one node with the other node. In network interface card, that is NIC. A network interface card, NIC, is a hardware component without which a computer cannot be connected over a network. So it is a hardware component without which you cannot connect a computer over a network. It is a circuit board installed in a computer that provides a dedicated network connection to the computer. It is also called network interface controller, network adapter or LAN adapter. Purpose: NIC allows both wired and wireless communication. NIC allows communication between computers connected. NIC is both a physical layer and a data link layer device, that is, it provides the necessary hardware circuitry so that the physical layer processes and some data link layer processes can run on it. Computer, client and server. In a client-server network arrangement, network services are located in a dedicated computer whose only function is to respond to the request of the client. So that is nothing but the server. This dedicated computer is your server, whose only function is to respond to the request of the clients. So what is it? There is one dedicated computer whose only function is to respond to the request of the clients. The server contains files, print, application, security and other services in a central computer. So client server is a centralized system. And in this, the server contains all the necessary things. That is, it contains files, prints, applications, security and other devices in a central computer that is continuously available to respond to the client request. The server will contain everything which will be needed to respond to the client's request. Networking protocols, you have TCP, IP protocol. There are two services, connection-oriented and connectionless services. Network layer provides two types of services to the transport layer. So the first layer is your physical layer. First layer is physical. After physical, you have the data link layer. After that, you have the network layer. After which you have the transport layer. So why are these services important? Services are needed because network layer has to provide services to the layer above it, that is the transport layer, and these services are connection oriented services and connectionless services. So connection oriented services, a connection oriented service is a network service that was designed and developed after the telephone system. So it is used to create an end-to-end connection between the sender and the receiver before transmitting the data over the same or different networks. So basically what is happening, A is connected via B using a network. Telephone system, A is calling to B, then it will be connected to B. Everyone will have a unique number. So A will only call to B using that unique number and they will be connected. So in connection oriented service, you have a connection which is provided between the sender and the receiver. In connection oriented service, packets are transmitted to the receiver in the same order the sender has sent them. So if the sender is sending 1 first, followed by 3, followed by 2, then 1 will be received first, 3 will be received second, 2 will be received third. So the way you are sending the packets, in the same way they will be received. So this 1, 3, 2 is not it's just an example, but the order will remain same. It uses a handshake method that creates a connection between the sender and the receiver for transmitting data over the network. Hence, it is known as a reliable network service. So when you are creating a connection, then if that connection is not broken, it is a guarantee that the data packet will be transferred from A to B. So when you say that it is a guarantee, that means it is a reliable network service. It gives the guarantee that the data will be transferred. Connectionless service is similar to a postal system in which each letter takes along different route paths from the source to the destination address. For example, I have A, there is B, and I have to send a letter to B. I can take any route. I can go to C and then go to B. First give some important message to C, then go to B. and give the letter, or I can directly go to B. So this is your route number 1. This is your route number 2. So we say that it can take different route paths from the source to the destination address. It is used in the network system to transfer data from one end to another end without creating any connection. So there is no connection established. So it does not require establishing a connection before sending the data from the sender to the receiver. It is a not reliable network service because it does not guarantee the transfer of data packets to the receiver, and the data packets can be received in any order to the receiver. So in connection oriented, we saw they were received in the same order as they were sent. In this, they are received in any order, and also there is no guarantee. It is not reliable. Connection oriented was reliable. Why is this not reliable? Suppose A is going to C, and suppose what message it had to give it to B, it is giving to C instead, and it is not going to B, or it loses that message. It reaches C and that message is lost before going to B. So it is said that it is not a reliable service because it can travel anyhow. For connection oriented, message has to travel from A to B only. Nothing will come in between. No C, D, E, F. Nothing will come. So that is more reliable. This is less reliable. Data packet does not follow a defined path. So this is a figure of connection oriented and connectionless diagram. Connection oriented, device A is there, device B is there. There is a stream of data flow. In connectionless, you have a data packet transfer. Data is transferred in the form of data packets. Packet 1, packet 2 and packet 3 are present. So comparison based on telephone system, connection oriented. Based on postal system, connectionless. Definition: it creates an end-to-end connection between the sender and the receiver before transmitting the data over the same or different networks. It is used to transfer the data packet between the sender and receiver without creating any connection. So in connectionless, no connection is created. In connection oriented, you have connection which is created. Virtual path: it creates a virtual path between the sender and the receiver. It does not create any virtual connection or path between the sender and the receiver. Data packet path: all data packets are received in the same order as they are sent. So I told you in that example 1, 3, 2, if they are sent in this order, they will be received in this order only. Whereas in case of connectionless service, not all data packets are received in the same order as though that they are sent by the receiver, as sent by the sender. So they are not received by the receiver in the same order as sent by the sender. Bandwidth requirement: it requires a higher bandwidth to transfer the data packet. It requires a lower bandwidth. It is more reliable. It is not a reliable connection service. Congestion: there is no congestion as it provides an end-to-end connection between the sender and the receiver during transmission of data. There may be congestion due to not providing an end-to-end connection between the source and the receiver to transmit the data packets. Example is TCP, Transmission Control Protocol, is an example of connection oriented service. User Datagram Protocol, UDP, Internet Protocol, IP, and Internet Control Message Protocol, ICMP, are examples of connectionless service. We are done with this.